Yes.
All right. So the first question you had was number 1, and this was the easiest one because number 1 looked like y equals 5x plus 8. Now, the one thing and only thing really that we talked about with direct variation yesterday is that direct variation looks like what?
Y equals k number times x.
Right. Y equals some number, which we call it k, times x. Okay? So if you have anything other than y equals some number times x, then that tells you that it is not the direct variation. This one is not direct variation because it has plus 8.
Plus 8.
This part right here, if that's all it was, would be a direct variation equation. But because it has this plus 8 added on to the end, that's what makes it no longer direct variation. Now, the next one, number 2, we have y equals 3.6x. So, is this direct variation?
Yes.
Yes.
Yeah.
Why is it direct variation?
There's no plus sign. Y equals k times x.
Because it's y equals some number, a decimal number, but again, there's no rule against your direct variation, the number being anything that is not a whole number or a positive number. It can be anything other than 0. So, it can be negative. It can be negative, it can be positive, it can be a fraction, it can be a decimal. Basically, anything other than 0 is fair game. So we have y equals 3.6 times x, so this is direct variation. Now, one thing that we did not talk about yesterday, so I didn't expect you to have answered it on the homework, but that you will need to know for the test, is after it asks whether or not it's direct variation or not, if it says, if it is, identify the constant of variation. Well, that's really easy. The constant of variation is what k is in our equation, which is just whatever's being multiplied by x. So in this case, we have y equals 3.6 times x, which means k is 3.6. So our constant of variation here is 3.6. All right. Number 3. Now this one's starting to get a little bit tougher because it's not in the form we need it in to begin with. Now, let me make sure we're clear about this. You cannot state whether it's direct variation or not until you put it in y equals form. Here I don't have y equals, I have 8y equals. So I can't decide whether it's direct variation or not yet. Before I decide that, I need to solve for y. How do you solve an equation for y?
I know. You do minus 8, and then you do minus 8 again.
Okay, why do you minus?
Because you said so yesterday.
Different problem.
You divide.
Y divides, Vaughn.
Because you multiply.
Okay,
You do the opposite.
this is solving. This is just solving equations. It doesn't matter that there's 2 variables in it. The same rules still apply. If we're multiplying something, we solve by dividing because that's the inverse operation. You can't get rid of a multiplication by subtracting. You have to divide. So I get y equals on this side, and I get 2 divided by 8, which is 2/8. Now, you could divide it out if you really want to. 2/8 is 0.25, and you can get 0.25x. That's fine.
I thought it was 1/4. Sorry.
Yeah, well, 2/8 is 1/4, remember, simplified fraction. All right, so this is 2/8x, or you could call it 1/4x, or you could call it 0.25x. All of them are the same thing. The main thing here is to realize that it's the number divided by the number, and then the variable just gets multiplied by that. So This is 2/8 multiplied by x, or 1/4 if you simplify it multiplied by x. Or if you wanted to divide it out. It doesn't divide out to a whole number, Taylor.
So is that a no, right? That's a no, right?
Well, if I have y equals 1/4 x, is that direct variation or not?
Yes.
Does it? Yeah, I mean it's y equals k times x. Well, y equals, that's k times x. So yes, this is direct variation. And our constant of variation is
1.4. 2.
1/4, not 1.4.
Oh.
Yes, 1/4 or 0.25 if you divided it out into decimal form. So our constant of variation is 1/4 here. Now, the next one is number 4. We have x equals 3y plus 1. Now, is this in y equals form?
No, because
No.
it's a plus.
Well, that's not why it's not in y equals form. It's not in y equals form because this says x equals, right?
But you have the thing that you can switch. What is that called?
The commutative property. It's got to be on the same side of the equation, and that just tells us we can switch the order. What we need to do here is solve this equation. So if I want to get y by itself, that means I need to get rid of plus 1 and
3.
times 3. So remember when we went back to solving equations with 2 steps, you always get rid of which first?
What's the multiplication?
No, the addition.
Yeah, remember it's reverse order of operations. Remember we talked about putting on socks and shoes, and the last one on is the first one off? No?
I do.
All right.
I don't. So you
Whatever's the
minus that.
last thing you would do, if I knew what those numbers were, I'd multiply and then add last, so that's the first thing I undo. So I'm going to get rid of the adding by subtracting. Now x and 1 are not like terms, so I have to leave it x minus 1. I can't combine them because one's a variable and one's constant. And the good thing here, I know y'all are going, oh wait, I don't really remember. This is good review because you do have a test that's coming up that's going to talk about combining like terms and things like that we've covered earlier. So, solving equations, all that stuff that it's been a little while since we've done is all coming back on the test. So you need to make sure you're reviewing and paying attention. It'll be the
Thursday.
Wednesday of the last week, I think.
Dang it.
Yes.
Wouldn't x minus 1 be w?
Wait, we have a test tomorrow?
Because w, x, y, and z.
Anyway, now I still don't know what y is. I still need to divide by 3.
It'll be 0.
It's really hot.
So I get x minus 1 divided by 3 equals y. Now, does that look like a direct variation equation?
No.
No.
It's on the wrong side.
No.
Well, it doesn't matter that it's on the wrong side. If this equals this and this equals that, it doesn't matter. We could swap the sides. What matters is, does this look like something times x?
No.
Something times x divided by 3.
All right. So, our equation here is y equals x minus 1 divided by 3, which is definitely not direct variation.
I can't see.
Why can't you see?
No, what don't? I want to sit right there.
Oh, kill me.
There, look. I want to sit under the air. That's so hot.
All right. Now, let's look at number 10.
What? Ooh, this is this.
All right, this one.
It's Richie's.
Yeah, it is.
All right, this one a lot of people had question on in my last class. Is this one direct variation?
Yes.
Okay, why?
Because y equals x.
Raise your hand.
The y is in the correction part and the x is in the correction part. And it should.
Okay, all right, so am I multiplying x by something? Is it y equals something times x?
No.
You're dividing.
Okay, guys. I have a whole lot of people telling me it's direct variation, but our definition of direct variation is y equals something times x.
This is x.
Is this y equals something times x?
No.
Okay. On the homework, did this one count as being direct variation?
Yes.
Yeah.
Yes. Because this is y equals x times something.
No, it's not a condition.
What? It's
1x divided by 7,
How'd you get
right?
one?
Because if you have remember, if you have a variable by itself, there's always one of them, right? 1x is the same thing as x. Remember back combining like terms, if I have 3x plus x, that's the same thing as 3x plus 1x, which is 4x. Remember that? Okay.
But then, how is
So,
it? It would just be 1x divided by 7.
no, remember we just looked at this example, 2x divided by 8, we said was the same thing as 2/8 times x, right? We can take the number, divide the number by the number, and then just multiply the variable out beside it. 1x divided by 7 is the same thing as 1/7 times x.
Because 1 times 7 equals 7.
Now, a lot of people here still having trouble. I know when we were looking at halving something. What's
That was
1/2
easy.
times 6?
3.
3, but that's also 6 divided by 2, isn't it?
Yeah.
Okay? Division can be written as multiplication. You just have to multiply by a different number. Okay? We're dividing by 7. Well, dividing by 7 is the same thing as multiplying by 1/7. So, the reason that this one is direct variation, even though it's written as division, is because it can also be written like this. Because multiplying by 7 is the same, or dividing by 7 is the same thing as multiplying by 1/7. And now you can see that it is direct variation. And the constant of variation is 1/7.
So it's 7.
Yes.
So it's like the variable y. Is it always going to be y or is it going to be x? Z?
It has to be y equals over there. If we're putting in direct variation form, it has to be y equals.
So,
Cameron?
So it doesn't equal 7, it equals 7.
It doesn't, no, it doesn't equal 7. It equals x divided by 7, which is the same thing as 1/7 times x. All right, number 11. We have y over x equals 2/3. Now again, this is one that it's really likely if you didn't solve it first,
I think I got that
probably a lot of you said this one was not direct variation.
Yes.
I said no.
If
I
you
think
solve
it
it for y, what do I need to do to solve this for y?
Ooh, I kind of know.
Someone?
You multiply it.
Because it's being divided, right? What is it being divided by?
X.
So that means I have to multiply it by
2/3.
x. And whatever I do on one side, I do on the other. X divided by x cancels out, because no matter what x is, if you divide it by itself, you just get 1. 1y is the same thing as y. So we get y equals 2/3 times x. Is that a direct variation equation?
No.
Yes.
Y equals 2/3 times x.
Sure.
Yeah.
Is it y equals k times x?
But I thought that you would have to have. Yeah, it would be considered.
Yeah.
And our constant, our variation is
2/3.
2/3. All right. Number 12. We have 3y equals 15 minus 6x. I need to solve for y, which means I have to do what?
You have
Divide.
Let other people answer.
Divide by 3, which means over here I divide by 3, and I get y equals. Now we could actually divide this out, but I'm not going to worry about it because even with it like this, you can tell. Is that direct variation?
Yes.
Does that look like just some number times x? No, because these are not like terms, so I can't combine 15 and minus 6x. So this is going to end up being
3.
not in. So this
Y
is,
equals 3x.
actually it's, no, if it were y equals 3x, it would be direct variation. It's going to be y equals 5 minus 2x if you worked it out, but I'm not worried about you working out. All I want you to see is at this point, this is a constant, this is a variable, I can't combine them. If they can't be combined, you're going to have y equals some number plus or minus some number, and it's not direct variation. Yes?
Why did it cost a variable?
Huh? What?
Why did it cost I literally
A
said.
constant.
Constant variable.
Independent.
Direct variation?
Why?
Because direct variation looks like y equals some number times x. There's my x. Am I multiplying one number by it? No, I'm multiplying it by 6 and subtracting that for 15 and dividing by 3. So is that direct variation? No. So there's not a direct relationship. It's not y equals just this number times x. It's y equals this number times x subtracted from 15 divided by 3. So not direct variation.
So how do you say it again?
Direct variation. All right, and then the last one we have is 13, which is 3xy equals 9x. Now this is probably the trickiest one for you guys because we have not done a whole lot with variables. Now,
He's like poking me with his thumb. I was putting like this and she moved into it.
okay, Sam, let's not be poking anyone because Sam, why don't we keep our pens well out of poking range of anyone? Now, all right. Okay, guys, so for here, if I want to solve for y, what am I doing to y here?
Dividing it.
Well, currently I am multiplying it by not just x, but 3x. So I'm going to divide by 3x on both sides. On this side, it'll cancel because 3 divided by 3 is 1, and x divided by x is 1. So you get 1y. And then I get y equals, and over here, 9 divided by 3 is 3.
Oh, that's right.
And x divided by x is
0.
1. So this is 3 times 1, which is 3. So I get y equals 3. Is that direct variation? No, because it's kind of missing that whole x thing, right? That's not there, so this one is not direct variation because it's missing the variable.
You get y equals 3 times x.
No, you don't get y equals 3 times x. You get y equals 3. Because to get y by itself, I had to divide by 3x. And if I divide x by x, then it goes away. So I get 9 divided by 3 is 3. And that's all there is. No, we haven't even started the next step.
All
right. Now, okay. What? Now, what we are going to do today is still direct variation, but we're going to be looking at direct variation from a table. Now, this is actually really simple stuff.
What color is it?
So if I have a table, and in one column I have the weight of something, so 1 pound, 2 pounds, 3 pounds, and in the other column I have the price, $3, $6, $9.
He has no words.
Okay, guys, this is your homework for tonight. You need to pay attention and be taking notes. Now, this is not an equation. but it still can represent direct variation, and that's what we need to know is, does this represent direct variation? Now, the simple way to check this is, since direct variation equations all look like this, right? Y equals some constant times x. Well, if that's the case, then if I solve this, if I divide by x on both sides, then I get y divided by x should equal k. Now, what this means is, whatever my y value is, if I divide it by my x value, it should always come out to be whatever that constant is, okay? Because remember, the whole thing with direct variation is you multiply every x value by the same number to get every matching y value, right?
Oh wait, can you say that again?
You're going to multiply every x value by the same number to get its corresponding y value. For instance, 1 times 3 is 3. 2 times
6.
3 is also 6. 3 times 3 is also 9. So the relationship between all these numbers is this one is 3 times that. Now, the simple way to check direct variation is, since that's true, if it is a direct variation equation, if you take the y value and divide it by the x value, so 3 divided by 1 is?
1.
3 divided by 1 is? Okay. 6 divided by 2 is?
3.
9 divided by 3 is?
3.
If it's direct variation, then the y value divided by the x value should always come out to be
The same
the same thing. Because the whole point with direct variation is there's the exact same relationship between every x and every y. So when you're dividing, you're finding what's the relationship between the y and x. That should be your k. If you're getting different values for k, that tells you there's not one specific constant you can multiply by, which tells you it's not direct variation. So let's look. So this one is, because if we did divide this out, we got 3 divided by 1, which is 3. We get 6 divided by 2, which is 3. And we got 9 divided by 3, which is 3, right? So that tells us this is direct variation. Now, an example that is the opposite. This is speed, and this is time. And I have speed of 10 miles an hour over 3 hours, speed of 20 miles an hour over 1.5 hours, and a speed of 30 miles an hour over 1 hour. So my k value should equal the y value divided by x. So what's the y value for this first one?
3.
3. Remember, x is always on the left or on the top, and y is always on the right or the bottom. So this would be 3 over 10. This one would be 1.5 over 20. And this one would be 1 over 30. Now, are those the same values? No, and if you're not sure, you can change them to decimal form. This is 0.3. 1.5 divided by 20 gives me 0.075. And 1 divided by 30 gives me 0.03 repeated. So, is that k value the same for all three?
No.
Which means there really isn't a k value, because k has to be the same. It has to be the same relationship between every x and y. And here we can clearly see that there's different relationships between the first x and y and the second x and y and the third. So that tells us that this is not direct variation, because the relationship between x and y. So all you have to do is in the table look at every single y and x. Now here's the thing. In order for it to be direct variation, that means that y divided by x has to equal the same thing for all of them. If it's not direct variation, all that means is that any of them, it could be that 3 of them are the same, but if any of them are different, then that means that that is not a direct variation equation. Okay? All right.
Why did you put the bottom numbers on top?
Because it's y, the y value divided by x is how you do direct variation.
Well, how do you
Because
know
remember,
that's
direct variation equation is,
Why just tell me?
the direct variation equation is y equals k times x, not y equals x times k. So you have to.
How do you know